Magnetostatics, Lekhun 3, problem 15. And the problem is given a long conductor with a current I, and it needs to find the magnetic field, the induction outside of the conductor. And the second is need to find the magnitude of the current as if magnetic field would be 1 Tesla, measured at a distance of 10 centimeters from the conductor. So here is the schematic presentation of the conductor. So here we assume conductor has a radius A, and inside is flowing the current. So in this problem, we can assume that the conductor is infinitely thin, since it's a long conductor. And then the magnetic field direction of induction can be found by right-hand rule. So that the thumb is pointing in the direction of the current and the 4 fingers curling around it. So you can see that it's a circular induction around the conductor. And we can define the radius of this circle, which is R. And in this problem, it's important that our R is larger than the diameter of the conductor. So that we have our enclosed path, and we can define dA, the tiny piece of this path. And to find the induction, can use Ampere's law in integral form here. And on the left side is integration, and on the right side is current times permeability of the free space, because in this case we don't have air around the conductor. It's in vacuum. So let's find this left part first. So to find the dN, we would use a cylindrical system of coordinates which has R, phi, and z axis. So our dl will be directed in phi direction. It's on the distance r from the center of coordinates, if we assume that this is our center. And it's d phi times d phi. So then the left side will be equal to our b is also in phi direction. Then we can replace it with d phi, because it's independent from z axis and independent from r also. And oh, sorry, it's independent from phi. It's dependent on the radius in phi direction, and then times phi r d phi. And we have integration, so our d phi, dl is along the circle, so it extends from 0 till 2 pi. And finally, then the answer is this part, scalar product of 2 unit vectors is 1. And then we have 2 pi r induction in phi direction. And going back to the Ampere's law, so we found the left side. It's important that the current is enclosed by the induction. So then we can write that's the solution of the first question. The second question, we need to find the current. The current I is using the same formula. And we have everything, so we can substitute values. 1 Tesla times 2. R is 10 centimeter from the conductor. And mu naught is a permeability of the free space. The value is given over there. And what do we get? The current is such a large current would flow in the conductor when we neglect the resistance of conductor to produce the inductance of 1 Tesla. And finally, can draw a small dependency of induction to the radius. So taking into account that our conductor has some fixed radius A, the dependency would look like it goes linearly to this A radius, and then it decreases rapidly. So closer to the surface is higher induction for the conductor in this ideal problem.